I'm going to use Desmos.com to investigate the transformations of quadratic functions. And in this part, the transformations are all going to stem from the parent function of quadratic functions. I'm going to type in here, which is y equals x to the second power. So the vertex, as you can see, is going through our origin of 0, 0, and it's going to be manipulated from there. And to help show those manipulations, I'm going to use vertex form of a parabola. And right after I type that into a line for Desmos, it asks me if I want to add any sliders, and yes, I want to add in sliders for A, H, and K. So I click all, and there we go. Before we start changing things, I want to make my blue function here, which is slightly shifted. I want to make this at the starting point where my parent function is. So I'm going to change my H values from 1, and I'm going to make them equal to 0. Same thing with my K value here. This is going to be 0 as well. And then I'm going to click my color here for my original parent function, so that's removed. Now, what do all these variables mean? I'm going to start with A, and if I make A bigger than 1, so I'm making it 2 here, 3, 4, so on, you can see that the parabola is getting narrower. Now, I'm going to bring in my parent function again, my starting point here, the red one, to see how much that changed. Another way to describe what happened is calling it a horizontal compression, meaning the parabola squished together and it got closer to that y-axis. To make the opposite effect, we're going to make my A value between 0 and 1. So let's see, between 0 and 1, for example, here's 0.7, you could see that the blue one is almost like pulled away from the y-axis. This is called a horizontal stretch. So you could also describe this as the parabola widening up or opening up more. So that's going to happen whenever the A value is between 0 and 1. So as you can see, I'm making it 0.2 here. It's even wider. Now if I make my A value negative, it gets so wide that it flips over the x-axis, and now it's opening up downwards. It's a flipped U. So whenever it's negative and it gets more and more negative, it flips and then just becomes narrower. Again, back to that horizontal compression. It gets closer to that y-axis. Now I'm going to move that back to y equals 1, where I started from, and I'm going to shift my h value. And as I change my h value, keep an eye on the vertex point. I'm changing my h value here to be a higher number, so as you can see it's 4, 5, and 6, and it's obvious that we're shifting to the right, and you can see that as my vertex changed. As we make my h value negative, it shifted to the left. As I change my k value, I make that positive, it looks like we shift up. And as we make my k value negative, it looks like it shifts it down. So the values for h and k will change the location of my vertex. To show that, I'm going to add in a note here, and we're going to say that my vertex is equal to h comma k. Okay, now let's do a quick example, and let's say I want to shift my original parent function to the left 2 times and then up 1 time. So that means that the vertex is going to be -2, 1. And if we look at the vertex form of a parabola right here, it looks like we want to take the opposite value of our h. So as you can see, our h, like I just said, was going to be -2. That means we want to add 2 instead, because in our formula we were subtracting. So there we go. And if that's kind of confusing to you, then just think of it as our h value, again, has to be a -2, and we're subtracting that from x. So if you're subtracting a negative value, that's the same thing as adding. And then our k value is 1, so we just plug in a +1, and there's our transformation from our original parent function, y equals x squared.